Okay, so solving quadratics, we've used factoring, and then we use the square root property. And now we're going to look at the quadratic formula. And so what you'll notice here, what's different with these equations that we're going to be dealing with is we don't just have the x squared, we also have the x there, to where the square root property wouldn't quite work in this form. And so now we're going to look at a thing called the quadratic formula. And so this is typically used on some of the more challenging problems where factoring won't work, or the square root property gets a little complicated to use that. And that's kind of another topic for a thing called completing the square. But let's go ahead and look at this. So the following equation is called the quadratic formula. So that's going to be this piece right here. The quadratic formula gives us another technique to solve the quadratic equation, a quadratic equation. This method will work regardless of whether the equation is factorable or not factorable. So even if it is factorable, it does work, but we typically save it for the ones that are not factorable. And on this first example, it is going to be a factorable question, but I like to kind of show one that works out kind of nice for the first example. So first, how do we even read the quadratic formula? Well, it's read x equals the opposite of b. Sometimes people say negative b, but a lot of times people like to say opposite to remind them that there's going to be a sign change there. So you can see right there we have that negative right there. So it's negative b or opposite of b plus or minus, and then we have the square root, the quantity square root of b squared minus 4ac. So you can see it's in parentheses right here in the phrase. And then it's all divided by 2a. So that's key. It's all divided by 2a. Sometimes students accidentally only divide the square root portion. So we want to divide the whole thing by 2a. All right, so now we are ready to find the solution to the quadratic equation using the quadratic formula. So like I said, on this first one, I actually kind of pick one where the numbers work out fairly nice. So right here in our example, we first have to put this in general form or standard form. And so what we have to do here is we have to set one side equal to 0. So what we had to do here is basically subtract 2x from both sides and then subtract 1 from both sides. And what happens is those cancel out, and that's where we get the 0. And then on the left side, we have the 3x squared, the minus 2x, and the minus 1. And none of those are like terms, so they all have to stay separate. And so once we have it in this form, what we can do is find those values from the quadratic formula, the a, b, and c values. And so those come as the coefficients here. So the coefficient of x squared is your a value, the coefficient of x is your b value, and then the constant is going to be your c value right there. So once we have that, it's time to kind of put the values in place where they belong. So I put the b right here, so negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So you get everything where it goes, and then from here you just have to be really simple with your algebra, careful with your algebra, and you should be okay. So first things first, we see we have the double negative right here. That'll simplify into a positive 2. So remember, up here we phrased it the opposite of b. So my b was negative 2. So the opposite of b, which is positive 2, plus or minus. Now you have to be careful here. A lot of times when students square negative 2, they come up with negative 4, but it's positive 4. Negative times a negative is positive. So negative 2 times negative 2 is positive 4 right here. And then next we want to go ahead and multiply these three values together right here. So 4 times 3 times negative 1, we end up with a negative 12 right there. And then in my denominator spot, we have 2 times 3, which is 6 right there. Okay, so then we have 4 take away negative 12. So that will actually turn into addition, and that's where we get that 16 right there. That's where that 16 comes from. And then we can square root 16, which gives us a 4. And then once we get down to this spot, now we need to look at this as a plus and as a minus. So as a plus, we end up with 6 divided by 6, which is 1. And as a minus, we end up with negative 2 over 6, which then simplifies into negative 1/3. Now, this problem, actually, we could have factored it if we wanted, but we went ahead and did the quadratic formula to kind of show you this. Moving forward, we're going to be working with problems that would not be factorable, and what's going to happen is our square root, we will not be able to, it will not be a perfect square, and so we might have to simplify it and adjust it, but we won't be able to actually square root the whole thing. So looking at our first example right here, so we're already in standard form, so we're ready to go. And so my a value is the coefficient of x squared, so a equals 1. And then my b value is the coefficient of x, so b equals 4. And then c is going to be the constant right here, so c equals 1. Okay, so identify your A, B, and C. Okay, we're good to go. Now apply the quadratic formula. So let me write that formula down again. All right, so now we're ready to go ahead and put things where they belong. So let's see, we're going to have x equals, so it's going to be negative, let's see, my b value is a 4, plus or minus the square root of 4 squared minus, that minus is part of my quadratic formula, and so is that next 4 right there. And then my a value is a 1, and my c value is a 1 also. And then all divided by 2 times a, so 2 times 1. All right, so let's see. I'm going to go ahead and square the 4 right here, and then multiply those three numbers, and multiply the 2 and the 1 right there. So let's see what we get. So now let's see, we're going to have that negative 4 out front, plus or minus the square root. 4 squared is 16. Then 4 times 1 times 1. So we're going to end up with a minus 4 right here. And then all divided by 2 times 1, which is 2. All right, so then now we can go ahead and do 16 take away 4. So we're going to have negative 4 plus or minus the square root of 12, all divided by 2. And we're getting close to the end, but we can simplify that square root of 12. So we want to break that apart. So we can break that into a square root of 4 times the square root of 3, and now part of it is a perfect square right here. So I can go ahead and square root that 4. So let's see, what do we have left now? So we have negative 4 plus or minus 2 square roots of 3 divided by 2. So it's all divided by 2. And so if they could all somehow reduce by 2, then we'll go ahead and do that. And so the square root of 3, it's along for the ride. Don't worry about that. Once you simplify the radical, whatever's left behind, you're not going to be able to do anything with. So you're really just focused on these three numbers right here. And so if they can all reduce by something, you want to go ahead and do that. And so they all are reducible by 2. So we're going to go ahead and divide them all by 2. So this would give me negative 2 plus or minus 1 times the square root of 3 and then divided by 1. Well, whenever you end up with a denominator of 1, you really don't need to write it in the form of a fraction. So we can go ahead and just kind of drop that and just write this as negative 2 plus or minus. And then 1 times the square root of 3 is just square root of 3. You don't really need to carry that 1 with you. And so this is actually our answer right there. And just kind of show you that this does work, because a lot of times when you do something like this, students don't really get an appreciation of, that this actually is a solution that makes the equation work. So I'm going to show you real quick. So let's see, what if we do negative 2, let's see, I could do plus or minus. I'm going to do minus the square root of 3. And so this is going to be an estimate. And so let's see, it's about negative 3.73, so on, right? That's why we like to leave it like that. We don't like our answers to be messy decimals. And so if we come up here, and I'm going to plug that into this equation and show you that it will equal 0. So what I'm going to do here is I'm going to take my answer and square it. So if I press square, it's going to say answer squared. So it's squaring my answer up here. Okay. And then plus 4 times my answer, so I'm going to sneak in my answer right here. So 4 times my answer, so it's referring to the value above, and then plus 1, plus 1. Let's go ahead and press enter, and look, there's 0. So if you were to plug that number in for x here and here and simplify the expression, it will equal 0. And the same thing would happen if I would have done plus. I would have gotten a different number, but that number does work. That number does work. Okay, so let's go ahead and try another one. All right, so this one here is not in that standard form that we want. So what I'm going to have to do here, now I could, if I really wanted to, I could move the 2x squared to the right side, but then it would become negative. And so I really like my a value to stay positive. So I'm going to move everything else over to the left instead. So I'm going to subtract those. And so let's see, I end up with 2x squared minus 2x minus 1 equals 0. Okay, and so that's going to be my A, that's going to be my B, and there is my C. So identify those. And then once again, I'll go ahead and write the quadratic formula down so we can see that. So negative B plus or minus the square root of B squared minus 4AC, all divided by 2A. All right, now let's go ahead and place things where they belong. So let's see, we're going to have negative 2, that's my B value right there. Let's see, plus or minus the square root of negative 2 squared minus 4 times, let's see, my A value is 2, and my C value is going to be negative 1, and then all divided by 2 times my A value right there. Okay, so let's clean this up. So we got double negatives right here, so that's going to become x equals positive 2 plus or minus the square root. See, negative 2 squared, negative times negative becomes positive 4. And then let's see, we multiply all that together right there. 4 times 2 times negative 1 is going to become a negative 8. And then all divided by 4. Okay, and so then here I have double negatives, so I'm going to end up adding 8 right here. So it's going to become 2 plus or minus the square root of, let's see, 12 all over 4. All right, so now we'll go ahead and break that apart, and we're going to get square root of 4 times square root of 3. And once again, we can square root the 4, so we're going to get 2 plus or minus 2 square roots of 3 all over 4. Okay, and then once again, you really just need to focus on these 3 numbers here. Are they all divisible by the same value? Can they all reduce by the same value? And in this case, yes, again, they can all be divisible by 2. So 2 divided by 2 is 1, plus or minus 2 divided by 2 is 1. Then you still have the times square root of 3. Don't want to forget about that. And then 4 divided by 2 is 2. And this answer is fine. This is a good answer. But typically, we don't include that 1 right there. It's kind of understood. So typically, we'll just write it as 1 plus or minus the square root of 3 over 2 like this. Either way is fine, but technically, this will be the preferred way of writing it. All right, so let's try another one here. And so to get this one started, once again, we want to put this in standard form. And so I'm going to subtract 10x from both sides. And I kind of need to wedge it in between those two right there. I need the x squared to go first, then the minus 10x, and then the plus 18. And so here, my understood value in front of x squared is 1. So my a value is 1. Here, my b value is negative 10. And my c value is 18. Okay, so once again, let me write that formula down for us. So x equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. Okay, so let's start plugging some stuff in. So let's see, we're going to have negative 10 plus or minus the square root of negative 10 squared minus 4 times a times c, okay, and then all divided by 2 times my a value. Now let's clean this up. So right here we got the double negatives, so that's going to become positive 10 plus or minus the square root, and then negative 10 squared, negative 10 times negative 10 is going to be positive 100. And then let's see, we got 4 times 1 and then times 8. So let's see, that's going to be minus, let's see, I believe that's going to be 72. Okay. And then let's see, now, let's see, the denominator, 2 times 1 is 2. And now we need to go ahead and subtract that right there. So let's see, we're going to end up with 10 plus or minus the square root of 28, and then divided by 2. So now with the square root of 28, we can break that up again, and it looks like it's going to be 4 and 7 here. And so once again, we can go ahead and square root the 4. So let's see, we're going to get 10 plus or minus, let's see, 2 square roots of 7, all divided by 2. And then, yes, they are all divisible by 2. They're all reducible by 2 right here. So let's see, that's going to turn into 5 plus or minus, and then the 2 turns into a 1. 1 times square root of 7 is square root of 7. And then we really don't need to have that divided by 1. So that is our solution right there once we reduce that. All right, moving on. Here we are. So we need to get this in that standard form. So we're going to add 8x to start and then subtract 2. So let's see, we've got 8x squared plus 8x, and then minus 2 equals 0. Now, if you recognize this, that they're all right here, they're all reducible by 2, that can make our life a little bit easier. Now, if you don't do it, it's not going to cause you to get the problem wrong, but it's going to make you have to deal with larger numbers. So something you can do, if you notice these are all reducible by the same value, you can go ahead and do that. And so technically what I'm going to do is divide everything by 2. I'm going to divide everything by 2. So I'm going to end up with 4x squared plus 4x minus 1 equals 0, because 0 divided by 2 is still just 0. And like I said, if you didn't recognize this, that's okay. You're still going to get the right answer. Your numbers are going to be a little bit larger, and you might have to reduce a little bit more at the end. But other than that, it's going to be pretty much done the same way. So here's my A, my B, and my C. And so let me put my quadratic formula up here. So let's go ahead and substitute our values in. So let's see, we're going to have negative 4 plus or minus the square root of 4 squared minus 4 times 4 times negative 1. And then all divided by 2 times 4. All right. So we're going to go ahead and take care of these 3 parts right here. So let's see what we get. X equals negative 4 plus or minus the square root. 4 times 4 is 16. And then let's see, minus 4 times negative 1 will be a negative 16. And then 2 times 4 is 8. So the double negative right there, we can actually go ahead and add 16 to the first 16 that we see there. So we're going to end up with negative 4 plus or minus the square root of 32 divided by 8. And then we have to figure out what to break this up into. And so look at your list, try to figure out what perfect square divides into 32, and you want to go with the largest one, which is going to be 16. So we're going to break that into 16 and 2. Okay. You might have been thinking, well, what about 4 and 8? You could break it up into 4 and 8. Well, that's fine, but then you'll have to break the 8 apart then also, because that can break into a perfect square. So it's always best to try to find the largest one. So in this case, it's going to be 16. So 16, square root of 16 times 2, we can go ahead and square root that 16. And so let's see, we're going to end up with negative 4 plus or minus 4 square roots of 2, all divided by 8. And then we look at those three values here. We say, okay, can they all be divisible by the same value? And yes, they're all divisible by 4. So what we want to do here is negative 4 divided by 4 is negative 1. Plus or minus 4 divided by 4 is 1. 1 times the square root of 2 will just give us that square root of 2 right there. And then 8 divided by 4 is 2. Okay, and this is it. Do not try to cancel these 2's. One's got a square root and one does not. So you cannot reduce that. Okay, I think I got one more slide. Okay, so this one looks like it's ready to go. And I believe these last two examples will have our, we're going to have to deal with the complex numbers. We're going to have imaginary solutions here. So right here, this is going to be my A, this is my B, this is my C. Let me go ahead and put up the quadratic formula right there. So let's see, x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 14, and then all divided by 2 times 1. All right, let's clean this up. So let's see, that double negative will turn into a positive 6 plus or minus the square root. Negative 6 times negative 6 is positive 36. And then let's see what we have here. We got minus 4 times 1 times 14, which will give us 56. And then all divided by 2. Okay, so then next we can go ahead and do 36, take away 56. So we're going to have 6 plus or minus the square root of negative 20 all over 2. Okay, so we have that negative value inside the radical right here. And so what we're going to have to do is an I is going to come out. And then also we're going to want to break the 20 apart into the square root of 4 times the square root of 5. So the I comes from the negative value inside the radical. And then we break 20 into 4 times 5. So we'll go ahead and square root the 4. So let's see, we're going to end up with 6 plus or minus, I like to write it like this, 2 and then the I, and then the square root of 5. So if you write the I in front of the 2, it's okay, but typically you're going to see most people write it in that format. And then all divided by 2. And then we're doing the same thing we've done on all these. We're just going to look at these three numbers at this point, and we see if they're all reducible by the same value, and they are. They're all reducible by a factor of 2. So divide them all by 2. 6 divided by 2 is 3. Plus or minus 2 divided by 2 is 1. And then 1 times I is I. And then 1 times square root of 5 is just going to be I square root of 5. And then the denominator in this case, 2 divided by 2 is 1. And so really I don't need a fraction because my denominator is 1. So we're just going to stop right there. Okay, last one. And this one should be pretty similar to the one we just completed, except that I have to first get this set equal to 0. So I'm going to have to subtract 3 from both sides. So let's see, I end up with 4x squared minus 4x, and then this will turn into a plus 7 equals 0. So here's my A, my B, and my C. And then let's go ahead and paste that. So there's my formula. And let's start plugging stuff in. So x equals, let's see, I'm going to have negative 4 plus or minus the square root of, let's see, b squared. So it's going to be negative 4 squared minus 4 times my a value, and then times my c value, and then all divided by, let's see, 2 times my a value. And so now it's just time to clean this up and just be careful with your algebra. So the double negative there, we're going to get 4 plus or minus the square root. Negative 4 times negative 4 is 16. And then let's see here, we have minus 4 times 7. And so just to make sure I'm careful here, I am going to use my calculator. So let's see, 4 times 4 times 7. So it gives me 112. So I need to subtract 112. And then divided by 2 times 4, which is 8. All right, so now I have to take care of the 16, take away 112. So I'm going to end up with 4 plus or minus the square root of, looks like 96, negative 96. And then divided by 8. Okay, so I know that I'm going to be getting an I out of this because of the negative, but now I got to figure out what to break the 96 up into. So remember, our perfect squares are 4, 9, 16, 25, 36, 49, and so on. And so you can play around with it in the calculator because you want to figure out the biggest one. That's going to make your life a little bit easier. Now, if you were to do 96 and 4, if you were to divide by 4, you would see that, oh, I could break it into 4 and 24, but then you would have to break 24 apart because you can break that into a perfect square. So I'm going to go a little higher up. Let's do 96, let's see, divided by 36. Okay, it doesn't divide evenly, so I can't do that one. Obviously 25 won't work, so let's try 16. Let's see, 96 divided by 16. There we go, 6. So I can break it into 6 times 16. So I'm going to break this into the square root of 16 times the square root of 6. And let's see, so now I'm going to have 4 plus or minus, let's see, this right here is going to become a 4i square root of 6, and then divided by 8, divided by 8. So once again, I just look at these three numbers, and I see they're all divisible by 4. So I'm going to reduce them all by a factor of 4. So 4 divided by 4 is 1, plus or minus 4 divided by 4 is 1, which then would just become I square root of 6, and then divided by 8 divided by 4, which is a 2. And then we just leave it like that. All right. So hopefully that helps you. If you need anything, just let me know.